Section 3 is going to be about hypothesis testing for population mean when population standard deviation is unknown. So what we're going to do is use a t-test. So I'm just going to start us out with the directions on how to do this. We're using a t-test because we have to use t-scores since we don't know sigma. Remember from confidence intervals, that was the statistic we used. So we use t-test for a mean, which is mu, when sigma is not known. Which, if you remember from chapter 6, I kind of said, you know, most of the time we're not going to know sigma if we don't know mean, so this is probably a better test for us to learn anyway. So step 1, what we're going to do is verify that sigma is unknown, just to double check. The sample is random, and n is greater than or equal to 30, or the population is normally distributed. Then we are going to state H sub 0, H sub A, and identify which one is the claim. Next, we identify the level of significance, which is alpha, same as it has been. Okay, here's where it gets different. Then we use the degrees of freedom. Remember from before that degrees of freedom is n minus 1, so it's 1 smaller than the sample size. And critical values to sketch and shade rejection regions. There's 1 rejection for a left-tailed test, 2 rejection regions for a right-tailed test. So what you'll see in the t-distribution table, you probably noticed this last time we were using it, but there's a level of confidence row, and then there's a 1-tail test and a 2-tailed test. So over here on the right, if you have a left-tailed test, then you're going to use a negative t-value. If you have a right-tailed test, you're going to use a positive t-value. And if you have a 2-tailed test, you'll use one of each. We'll practice that here in a little bit. We'll just make a little chart indicating that. So for a left-tailed test, this area here is alpha. And we're going to use a negative t-score. And we are going to use degrees of freedom equals n minus 1. And we're going to look up the row that says 1 tail and then the alpha score that we're using. So it's actually going to be the same thing for the right-tailed test, except for this is going to be a positive t. Then when we have a 2-tailed test, remember that each of these is alpha divided by 2. We're going to have a negative t-score and a positive t-score. We're still using degrees of freedom equals n minus 1, but now we're going to look up in our table for the row that says 2 tails, comma, the alpha score that we're given, the alpha value that we're given. Step 5 is going to be to find the standardized test statistic. In previous sections, we've been using the z-score, but this time we're using a t-score. So it's t equals x bar minus mu divided by, since we don't know sigma, we use s, which was the sample standard deviation, divided by square root of n. Step 6 is to decide. Remember, we reject h sub 0 if t is in the shaded region. Otherwise, do not reject h sub 0. And step 7 is interpret the decision in the context of the original claim. And remember that that uses the precise language that we have gone over lots of times from this little table. That's your step 7. Alrighty. We're going to do a couple of examples. We're going to start with this one. Number 17, which happens to come from page 384. And we're going to go through all the steps that we just talked about. A credit card company claims that the mean credit card debt for individuals is greater than $5,000. You want to test this claim. You find that a random sample of 37 cardholders has a mean credit card balance of $5,122 with a standard deviation of $625. At alpha equals 0.05, can you support the claim? So our very first step was verify sigma is unknown. Nowhere does it tell us about sigma. This down here is telling us the standard deviation for our sample of 37 cardholders. Our sample is random, it tells us here, and the sample size is bigger than 30. So step 1 is good. Step 2, state the null hypothesis and the alternative hypothesis and say which one is the claim. It's claiming that the mean credit card debt is greater than 5,000. Greater than does not have an equal to in it, so that has to be our alternative hypothesis. So the mean has to be greater than 5,000, which means our null hypothesis is the mean is less than or equal to 5,000, and our claim is h sub a. Next step is to identify level of significance. So alpha equals, it's given in the problem, 0.05. And then I go ahead and draw my curve. Since my alternative hypothesis is greater than, this is going to be a right-tailed test. I've got to figure out my t-score based on my degrees of freedom and look stuff up in the table. So my degrees of freedom is my sample size, which was 37, minus 1. So degrees of freedom is 36, and I have a one-tailed test. So I go to my table. I'm on 36 degrees of freedom. I look up to the top. I need a one-tailed test, and they told me that alpha was 0.05. So I'm in this column here, follow it all the way down to the row I was on, and my t-score is 1.688. That is a positive t-score because it was a right-tailed test, so 1.688 is my critical value. Then I'm going to figure out my standardized test statistic. So I need t equals x bar minus mu. X bar is this, 5122. minus mu, which is my claimed mean of 5,000, divided by S, which was 625, over square root of n, which was 37. So I'll put that in my calculator. $625 divided by square root of 37. 5122 minus 5,000 divided by that number. My t-score is 1.187. Remember that zero's in the middle, so 1.187 is about there, since 1.688 is there. Since my standardized test statistic is in the clear, I do not reject H sub 0. So then I have to go back and interpret that. I am not rejecting, and the claim was H sub A, so not reject H sub A's claim. There's not enough evidence to support the claim. So I say at the 5% level of significance, there is not enough evidence to support the company's claim. That the mean credit card debt for individuals is greater than $5,000. Let's do one more from this section about annual salary. Following those same steps. An employment information service claims the mean annual salary for full-time male workers over age 25 and without a high school diploma is $26,000. The annual salaries in dollars for a random sample of 10 full-time male workers without a high school diploma are shown in the table at the left. Oh, we're going to need a table at the left. Let's see. Here we go. Right here, table at the left. At alpha equals 0.05, test the claim that mean salary is $26,000. Now, one thing that's missing in this problem is they did not tell us that annual salaries are are normally distributed, but we're going to go ahead and make that assumption because otherwise we wouldn't be able to do the problem because that's one of the things we have to check in step 1. So just for purposes of what we're doing here, we're going to make that assumption, even though they didn't tell us that. Okay, here's our table. Okay. Step 1 also includes verifying that we don't know sigma, which we don't. In fact, we don't even know the sample mean or sample standard deviation. We're going to have to figure that out for ourselves. And the sample is random. It tells us we did a random sample of 10. So we're good there. So then let's go ahead and get H sub 0 and H sub A and figure out which one's the claim. An employment information service claims the mean annual salary for full-time male workers over age 25 without a high school diploma is $26,000. So that's an equal. So our claim is that mu equals $26,000. And so H sub 0 is our claim. And then H sub A would be mu is not equal to $26,000. Next thing is identify the level of significance, and that is alpha equals 0.05. And then use the degrees of freedom and critical values to sketch and shade our rejection region. So we have a rejection region with two tails, since it was a not equal to for H sub A. And with alpha equaling 0.05, remember each of these is half of that. But what we get to do is look this up on our table. So we have degrees of freedom equal to our sample size minus 1. So we've got 9 degrees of freedom, and we have a two-tailed test. So, oops, that's the wrong table. Let's use the t distribution. There we go. With 9 degrees of freedom, and we have a two-tailed test, so we need to look on this row here, and alpha is 0.05. So for two tails, alpha equals 0.05. We're looking in this row down to 9 degrees of freedom. So our t-score is 2.262, which means we have 2.262 here and negative 2.262 here. And then we have to find our standardized test statistic. Okay, that's going to be a t-score, and it's going to be t equals x bar minus mu divided by s over square root of n. But we don't know x bar and we don't know s because it's not given in the problem. So we're going to have to figure that out on our calculator. We're going to let our calculator do that in stat edit and put our salary data in there. And then we do stat calc, one variable statistics, using list 1. And it gives me x bar is $25,352.20. So t is 25,352.2 minus mu, which is my claimed mean, 26,000, divided by s over square root of n. S is 3197.08, so 3197.08 divided by square root of n, which was 10. Then we'll calculate our t-score. I'm getting t is negative 0.641. When I put that on my chart, that's just to the left of 0 on my drawing. And that's in the clear, so we do not reject H sub 0. Remember that H sub 0 is our claim, so we're not rejecting our claim. H sub 0 is our claim. So we're saying there's not enough evidence to reject the claim. And this would be a super long sentence if I had enough room for it. So I'm just going to write part of it, and I'll say the rest. There is not enough evidence at the 5% level of significance to reject the employment services claim that the mean annual salary of full-time male workers over age 25 without a high school diploma is $26,000.